Tutorial I'm going to solve one more problem. Again the same thing, continuous state tank fermenter. I'm just going to read the problem. So what we are doing is, like, I already derived how to theoretically get your productivity if you know the kinetic constants. So if you know how fast your microorganisms are replicating inside your reactor at different substrate concentration, from that you can get your kinetic parameters, which is your Monod constants. And if you know the Monod constants, as the chemical engineer, you know how your continuous state tank fermenter works. So you're going to use all these values to to perform a mass balance and calculate productivity, or if there is a steady state already reached, so you can even calculate your substrate concentration, microbial concentration at steady state. Yeah, so this is like, to me this is really beauty of chemical engineering. So you perform some experiment using some batch experiments, and then in batch mode, sorry, and then you get kinetic constant, and from that you design a continuous process. So this is such a cool example. And I'm going to solve this problem. So let's read the problem. The steady state substrate and biomass concentration for a continuous state tank fermenter operated at various dilution rates are given below. So we have some data as a function of your dilution rate. So given that the fresh feed concentration is 700 milligrams per liter, calculate the values of Monod constants. Okay, your specific growth rate, and you have to calculate the Monod constant Ks, and the yield coefficient Y, and the endogenous respiration coefficient. So which means the your cells are consuming some substrate in order to maintain, for cell maintenance, apart from from its requirements to, how do you say, like, so your cells can consume your substrate and then convert them into products, which may be more microorganisms, or it can be new products. At the same time, it also needs some level of substrate in order to maintain so that they can do their job, which which is to which is to consume your substrate and convert them into products, and also to exactly this endogenous respiration coefficient. It corresponds to maintenance coefficient, and it needs to use some energy to maintain its cell structure, or secrete some enzymes which actually do the job of converting your substrate to products. So 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 I already talked about this in the PowerPoint. What is a maintenance coefficient, and how it's connected to your Monod constants, or how it's related to your specific growth rate. Yeah? So all we are going to do is you're going to use that expression and then calculate whatever they asked. So let's solve this one by one. So what are the values I gave you? I gave you dilution rate, which is here. This is your dilution rate, and then you have your substrate concentration and your microbial concentration, all at steady state. Anyway, you are dealing with CSTF, yeah? So obviously it's easy to work only at steady state condition, especially at steady state conditions. So I derived this expression already. If not, you must check my previous notes. I think lecture 8, I think. So this module is not a tough one. It's really easy to solve. So all you need is to plot this value in y-axis, and then you can plot 1 by d, or you can, yes, you have to plot 1 by factor in the x-axis. From that you can calculate your yield and also your respiration coefficient. Yeah? So let's do that. Let's calculate 1 by d. Let's calculate 2 minutes. So this is 1 by d, so that's equal to So these are the values you have. So from this you can plot them. Yeah. So it's better to use Excel sheet. If you see this, the difference in values, they are too low. Yeah, it's better to use Excel sheet. So 1 by dilution factor, say ranging from 16, and then it ranges from 2.0 to 2.030. You'll get somewhere like this. So from the best fit line, so your intercept, sorry, we'll have some intercept. Your intercept will be equal to 1 by y, so that will be equal to 2.0033. So therefore y will be equal to 1 by 2.033, so it's approximately 0.5. It's 1 by 2. Yeah? So that's your yield. Your yield is 0.5, and your slope will be equal to kd by yield. So this is equal to 0.0018. So therefore kd will be equal to, for your exam you can use your graph sheet or you can use your Excel sheets, Excel normal Microsoft Excel. So it's up to you to decide. kd by y just substitute your yield value here, 0.5. So that should, kd value should be, you should get this value, just to check it by yourself, 0.009 per unit hours. And then we have to do something else. I think I derived another expression. So y by mu, I'm just checking my notes, I don't remember now. Yes, I derived one more expression relating your microbial concentration as a function of kinetic constants, Monod constants, x S0 minus s, that's equal to ksy. I derived this already. So from this one you can easily get your Monod constants. Yeah? So x by d S0 minus s is a function of 1 by s. If you get something like from there, you can calculate your mu m value and ks value. So try to do it by yourself. Yeah. So this is a straightforward problem. You can calculate it really easily. And yeah, I think this is easy. Yeah? You can do it yourself. Yeah? All you need is to plot, take this value and calculate this value, and calculate from the slope and intercept. You can calculate your Monod constants. So I'm going to stop recording, so you can do this by yourself. Yeah, all you need is to use an Excel or a graph sheet. It's straightforward problem. And thanks for listening.